Hello, Dr. Lai. Today I'll be presenting about the application of first order circuits in pacemakers. So, what exactly is a pacemaker? A pacemaker is a device implanted near the heart in order to generate an artificial pulse to the heart in order to keep it beating, especially for those that have critical heart conditions. So, why exactly do we need a pacemaker? Well, you see, usually the sinoastrial node are the one that is responsible to generate the signal to the heart, and it usually maintains a beating per minute of about 100 times per minute. So you see, even a slight disruption in this signal processing will cause a very big problem to us. So you see, this is when the pacemaker comes to play. Pacemaker will generate a pulse whenever there is an abnormal activity in the heart. So this brings up a question: does a pacemaker completely replace the function of a sinusoidal node? Well, not exactly. The pacemaker will only fire a pulse whenever they detect an abnormal activity in the heart, and this pulse will need to be timed very perfectly. So wonder why? So why does it need to be timed very perfectly? The answer is to not interrupt with the order of beating for the atria and ventricles. As we can see in this diagram over here, there is a very specific synchronization between the atria and ventricle in order to maximize the amount of blood pumped by the heart. So it's very crucial in order to time the pulse very perfectly for this. So how exactly do we time it perfectly? Do you maybe use a clock? Use a button? So the answer is none other than a first order RC circuit. So what is that? Well, it is a simplest version of a circuit with a resistor and a capacitance in it that can be described by a first order differential equation. So in this equation, we can see how its output, like the voltage over time in the capacitor, changes over time. When talking about electricity, it is best for us to use the analogy of a water. And for this case, as the capacitor, we will take an analogy of a water tank. Imagine the water level increasing as water going through it. This can be seen as a voltage. And when the water level reaches a certain threshold, the water will start flowing from the pipe. And this water flow can be counted as a current flow. Therefore, when the voltage reaches a certain threshold in the capacitor, then the current will start flowing. So let's look a bit more into this threshold. So the threshold is basically influenced by the time constant, which is defined by the product of R times C, which is the capacitance. So therefore, the capacitance can directly affect the threshold, as you can see this question over here. So this threshold are basically what we use as a timer. Like, we can time the threshold to be met when we need the heart to start beating, but we still need to look about how exactly they time it to only beat when there is an abnormal activity in the heart. So let's look a bit into it. So let us focus on the algorithm here. So basically the capacitor gonna start from zero, basically no voltage in it, and the voltage gonna keep building up. And during this build up, the sensor is gonna be detecting on the heart activity and if there are any abnormal activity going on. And as the timer goes full, or basically when the threshold capacity is met, then they will do action based on what we detected earlier. If there are in fact abnormal heart activity, then it will signal the power system in order to generate the pulse to the heart in order to keep it beating. However, if there is none, then the capacitor will empty and start from the beginning back. So that's how the timer works. So let us conclude what we have learned today. Basically, the pacemaker is a device that restores the heart pulse in the case of an abnormal heart activity. And how do they do it? They basically apply the concept of first order RC circuit uh, to time the generation of the pulse in order to avoid messing up the synchronization of the heartbeat to maximize the amount of blood that is pumped by the body. So that's it. Thank you for your attention and bye.